Hello everyone. So today we are going to see a little bit moderate level questions for TP on grids. So I could say this as TP on grids part 2. Okay. So what are we going to see? Like last time we have seen that you will be given start position and ending position. Now, what does this mean? You'll be given ij of starting position and ieje means ending position, is and js of start position and ie and je of the ending position. So you are given this fixed indexes like 0, 0, 2, m minus 1, n minus 1. Okay. Now, uh, what is the issue? Now, what this kind of things does, like some moderate kind of questions, gives you the start position maybe, or just give you the starting row. Okay, that you can start from any column of zeroth row. Okay, in the grid, you can start from any column of the zeroth row, and you have to reach until of any column of n minus one row. Now this should be given to you. That so you will be given um, you will be given is and you will be given ie, but j's are not given. Okay, so you are not sure about the columns, or it could be vice versa. You will be given the columns that you have to start from the first column, reach until nth column, but in any row you can go, but the approach or the question is like you have to do the minimum of sum, maximum of sum, such kind of question. Like you can stop at any point, but the point where you are stopping, the sum should be minimum or maximum, whatever is given in the question. So now your condition has changed a little bit. Only one attribute of the index is given, which is called the start I, which is called the I or maybe J. Anything would be given to you. It depends on you now that how you solve the question. Okay. So for this kind of questions, what you will do? So if only start row is given, no column is given. Okay. If only start row is given, let's say zeroth row. Okay. Then call your dp function or call your recursive function, which is internally calling dp for all columns in zeroth row. So fix fix the j for like fix the j for like 0, 0, then 0, 1, then 0, 2 until 0 m minus 1. So that means you are fixing the row, but your columns are varying. So you are calling this every time, and then you do minimum of all when you reach the end row. Okay, this is when you are given just start row. Okay, nothing else. Okay, but you'll also be given the bottom row. Okay, because we are passing the solve function from start indices. Okay, that's why if only one attribute is given in the start index, if it could be only I or it could be only J, then we do for every other index. If I's are given, we'll assume all other J's and we'll do minimum or maximum of all depending on the question given to you. But then if along with the start only end row is given, like no column is given. Okay, you have to reach last row, like n minus 1th row, but you are not sure which column. Then your base condition changes in this case. Here, your base condition changes. Okay, here you have to change your base condition because now, anyways, you will be passing 0, 0. Because you are given start. Okay, if start is not given, you will pass for all this 0, 0, 0, 1, 0, 2. You'll do for all of this. But you didn't have any condition in your main function for ending index. For ending indexes, your condition lies in the base condition. So your base condition changes respectively. Whatever is given to you, accordingly it changes. Okay, so we have a simple question. The question says, let me just paste the question over here. Okay. Mm, Okay. So the question says that given a triangle array, okay, given a triangle array, you have to return the minimum path sum from top to bottom. Now, for each step, you may move to an adjacent number of the row below. You may move to an adjacent number of the row below. More formally, if you are on index I on the current row, you may move to either index I or index I plus 1 on the next move. Let's say the test case given is this. Okay. So the test case given is this. So we have on first row, we just have 2. On second row, we have 2, 3 and 4. On third row, we have 6, 5 and 7. And on fourth row, we have 4, 1, 8 and 3. So this is your triangle array. Okay. Now you have to return minimum path sum from top to bottom. Now, of course, top is fixed, like top means 0, 0 only. Because it is triangle, the upper element is only 1, which is 0, 0. Right? Okay. So you have to move from 0, 0 to downwards. Now you have to move from top to bottom. So bottom is also fixed. Like from any four of this you can. Like it could be 4, it could be 1, it could be 8, it could be 3. Now you have to do the minimum of all. What is the minimum? Okay. So the question says that you have to move from top to bottom, and at every step you move to an adjacent number of the row below. Means you can move one step below. More formally, if you are on index I on the current row, so on the current row you are here, okay, you may you may move to either index I or index I plus 1 on the next row. So you can stay here or you can move downwards. Okay, no other steps you have. You if you are on index I on the current row, you may move to either index I or index I plus 1 on the next row. So on the next row it is saying. Okay. Okay, so if you are on 2, you can either move to 3 or to 4. Okay, these two conditions you have, the same index on which you are or the adjacent one. So if you are on 3, you can either move to 6 or on 5. You cannot move to 7. And if you are on 4, you can move to 5 or 7, not on 6. I hope you got. Because this is index 1011. This is index 202122. So from this 0th column, you can move to the next row of 0th column or first column of next row. From this 1, 1, this is first column. So you can either move to first column of next row or second column of next row. I hope you got it. Okay, fine. Fine. We know now both the conditions. Now, here ending row just changes. So ending row is given. Okay, that could be your n minus 1. Okay, and column is not given. It could be either 4, 1, 8 or 3. Four values are given at the end row. It could be to anyone, to this or this. Now how we'll decide now when to stop? So a base condition is fixed now. Okay, you have to do the minimum. You have to do the minimum, and your base condition will be what? If your I is equal to n minus 1, this means your row, then you will return whatever is the number on that index, which is grid of ij. J could be anything. We are not putting the condition of j in my base condition, but every time I have to do minimum. So anyways, the minimum of all this will only be returned when I'm returning my answer. Cool. Let's solve the question and you'll be more clear. Okay, so I can share the question tab over here, and we are done. So we have two steps here, either to move down or to move the diagonal. Okay, means one step above. So okay, so let's have an array of size 205, 205. So enter dp of 205, 205. Okay, now we have fixed this, how many are the length, but you didn't have fixed number of columns in each row. So you just have fixed number of rows. We cannot make the save function over here. We just have to do it manually. And anyways, it's 2, we can do it. Okay. So this triangle dot size is our number of rows. Here 4. Okay. Memset dp minus 1 size of dp. Okay. Now we have int solve wherein we'll pass int I in j. Okay. Because j is also changing. You are either moving, you're moving to the next row, but you're moving on the same index or on the adjacent index. Okay. And we have vector of int ampersand triangle and int n. Now, if your base condition is if I is equal to n minus 1 means you have reached the last index, you will return triangle of ij. Cool? You'll return triangle of ij. Now, here for the j condition, like if I am on 3, for sure I have the number below it and for sure I have the element on adjacent of it. You could see. So there is no chance of j going out of bound over here. Means j could be j or j plus 1 for I plus 1 row. Okay. So if you are on 3, 4, okay, if you are on 3, 4, you could move to either 6 or you could move to either 5. Okay. So okay, if dp of ij is not equal to minus 1, we'll return dp of ij. Now there are two cases. You can move down. Okay, initially putting everything as int max because we have to return the minimum. And diagonal, which is again I'm putting into max. Now what you can do is, your down will be, if the condition of safe is only I plus 1. If I plus 1 is less than n, then you can do this. You can move to the next row. Then uh, your down will be taking this number, which is triangle of ij, and moving one step down. So I plus 1 and j remains same with the triangle and n. And diagonal will also come under this condition. Means I don't have to check for j plus 1 less than its size. Okay. Because for any element, if I'm going one step, one row below, it for sure has the next adjacent element because this is triangle. Okay. So this will be again triangle of ij plus solve of I plus 1, j plus 1, triangle and n. Okay. And we will return dp of ij as minimum of down comma diagonal. Cool. Okay. We'll pass solve function for 0, 0, triangle and n. Cool. Okay. I hope you got it very clearly. Okay. So this is minimum falling path sum. Now, here both of the conditions are not given. You are given n cross n matrix and you have to return minimum sum of any falling path. Now, falling path could start from any element in the first row and it chooses the element in the next row that is either directly below or diagonally left or right. And you have to reach to the bottom row. Okay. Because it's falling path, it should go from top to bottom. So your starting row is 0, your ending row is in minus 1. Okay. And the column of any of the starting or ending position is not given. So you have to do both the cases. You have to do the for loop for all the columns when you are starting, solve your problem for each of them and find the minimum and then return. Okay, so this 157, this 148. Both of this could be correct with the 13 answer. Okay, here also minus 19, minus 40. Both of, sorry, minus 19, minus 40, whatever is minus 59 is your correct answer. Okay, so you can do it by yourself. Now in the next video, I'll try to cover a problem, a little harder problem of the grid, wherein we could take the 4 variables, I think. No, 3 variables, which is 3DTP, but again on the grid. So see you until then. Bye bye. Like, share, and subscribe if you have learned a lot out of this.